This will once again be introduction to the Endless Runner in Godot, but the beginning should be a smooth sailing. Okay, so at the beginning, let's create for ourselves a small little scene. I will call this one this time main. This will be our controlling everything scene. We will be spawning everything in here. Let's create ourselves a character that will be controlling. Let's make our character have a sprite 2D, and as a sprite we'll be using at least now the default icon. Let's see if it works. Okay, so now we'll do rename the scene. I've also checked, and the docs recommend calling scenes and scripts using the snake case, so starting all the words with the lowercase letters and separating them with underscores. So let's just throw a main open. Okay, we've got it running. Maybe change the music a little bit cold. Let's also add a camera to the in here, so that will be controlling itself, but keep the camera as a child of the main, not as a child of a character. What's up with this music? Now we've got it like this. Maybe let's expand our window a little bit. Let's go to the project settings, the window here. Maybe let's not overdo it and just keep it as a HD. If I am correct, it used to be like this. And maybe instead of increasing the window size, let's try decreasing the sprite size. I think I should be able to throw some scale in here, wherever what it was, scale in the transform. Okay, make it 0.5, half of the previous size should be better. Now we don't want to control the player spawn like this, so let's export our, maybe first let's rename the character body to D, this one, to the player. Here we'll be starting with uppercase everywhere in our editor. Wait, I didn't mean to change the type. I want to rename player. Okay, and now we'll export this node as a, let's say, branch as scene. Now let's also create a folder for our player stuff, and we'll be saving player stuff in here, but at least for now I'm not sure. Well, at least for now keep the main scene in our main directory. We'll see later. Now if you have it like this, we can load the player from the script now. So I will remove it from here, but it will say we stay as a branch in the folder. And let's add a script to our main scene. Yes, let's call it main GD. Now we want to be able to spawn a player from the script, but we need to get a reference to our player. To do it, I think we'll make a singleton, so a global script basically. I will create a new folder in our game directory. I will call this one globals. You check the project organization guide. You should also use a lowercase for folders. Okay, and in the globals folder, I will create a new script, and I will call this one. Preloads, as in the preloaded variables. Where is it? Basically, in this preload, I will create a constant variable, and because the constant, I will use all the uppercase letters, and here I will preload a scene, the player, and I will be able to have a reference to our player in here, and it will be easily accessible from every place in my project. Now I have to go into the project settings, and here in the auto load we have to grab this global script and add. Okay, here you can change the name. I will leave it as preload starting with a uppercase letter. Now in my main scene I can create a local reference to a player. Let's create a ready function, and I can either load a player in here, or I can load it where I've declared the variable. I think I will do it in the ready function. If it won't be so pretty, then I'll change it later. So here let's make a player. What if I say, because this is an instance, wait, this is a scene. Is scene unknown? Probably. Okay. So let's say that I will static type this one to the or character body UN. Semicolon means that this variable will have must be of the specified type, and doing it like this in Godot 4, so giving every variable a static typing improves performance. So now we want to make the player equal to the preloads dot player. I think you're supposed to use the instantiate. Instantiate. Let's check whether it crash or not. Okay, it did not crash, so maybe I've done properly. Let's try setting the position of our player to vector to 0 0, and we should be able to see it. We don't, meaning something is probably wrong. No, we just didn't add a node as a child. So now when we run it and we go here to the remote, we can see that our main has nothing. But if we now add a child player, run, we can see the player, and in the remote we can see our child player. Okay, I can stand this sound. Give me a second. A little bit better. Now I probably would like to add some movement capabilities to my player, or maybe not. Maybe we don't want the player in the middle. We want it a little bit. We want it to be positioned a little bit lower, but here we don't want to statically type the position. So there is a function like get viewport rect size of this one, and this is basically the size of our the size of what you see as a, I don't know, player or whatever you want to call it. So we'll set the x of the size as x of position of player. We'll also grab this and grab the y, run, but now the player is, and we want our x to be in the middle, but we want to keep the y as it was. Now if I'm correct, the player spawns somewhere here. Let's decrease position a little bit here, and it should be like in the... Okay, maybe I'm not correct. What's the problem? Okay, I wanted to reverse it like this. So the player spawns here. Okay. What is this? Okay. I see what's the problem now. The problem is that if these are our x and y axis, and we had camera here, while the viewport was like here, and we were spawning our player here all the time, and if we want to keep spawning him here with the camera direct in center, then we can I don't know, divide by keep the x on 0 and divide by 4, I think. So this is not straightforward. So let's keep the camera fixed top left now. And now the other problem is that the player sprite is positioned in half. So we want to put him higher, but by using the variable, not a constant number. So we'll go to our player scene. Okay, so the player doesn't have a script yet. Okay, let's create a script in here. And we want to create an export variable. Call this one a sprite. Export var sprite. Give it a static typing, sprite 2D. And now the sprite attribute, I think it's called, or parameter shows up here. We can drag a sprite, save, and now we can access this attribute outside of this class. So here we can simply not extract, what's the word? Subtract. We can subtract part of our player sprite, like we can grab the player sprite, get rect y, let's see how it looks. It crashed. Size, I think. Okay, as you can see, it moved up a little bit too much. Let's divide it by half. Okay, good enough for now. Or maybe by 4 times 3. Wait, did I mess? Maybe just by no. This is the perfect one. But what's maybe by 6 times 5? Yeah, damn it, I don't really want to think about that, about the math, so I'm just freestyling some numbers. Let's keep it like that. Let's create ability to move, and by move I mean to control the player. Because it's a character body 2D, we have two prepared methods that are used for moving, move and slide and move and collide. Let's create our physics process check function. Here let's use move and slide function, and this function moves by using the velocity parameter built in the character body, and it controls, it's basically a vector, so direction times shift, or whatever you call it professionally in the physics. So we need to speed for our body. Let's try 150. We are using colon and equal sign. I think that's an equal sign. Define both the type and the value of our variable. Now we need to set the velocity, and we want to be setting it based on our inputs, so press arrows or whatever you want to press, and we want to be checking it every frame constantly. That's why we're putting it in the physics process function. So here we'll be setting value of the velocity. We change the color because this is a parameter. And there is a function, like I said, the velocity will be a vector too. And there is a function for grabbing inputs now. It's input dot get axis, and we are concerned with the left and right inputs. We don't want to be moving forward, so we'll grab the left and we'll grab right. And why is it crying? Okay, it's crying because this is not let's see how does it look like. Okay, also you're probably curious, the inputs are predefined. You can go in the project settings, input map, show built-in actions, and you have some predefined inputs here we can also modify. So here in the Y left, I have only left key button. Let's also add, this is, as you can see, the keyboard key. I would like to add an A here for the WASD movement. Okay, and in the UI right, I will add keyboard D. Those. Okay, now when we run, we'll have it printing here in the console, and now when I press the left key, I'll guess -1. When I press the right key, I will guess 1. When I press both, I will get 0. Okay, so the problem was that this input function was giving me only a single number, and this is a vector, so we need both numbers, and vectors are x and y, so here we'll need to add a 0 because we're not moving up and down. And this is only a normalized vector, or maybe not normalized vector, it's not a normalized vector. This is just a direction, so we need to multiply this by our multiply by our speed, and now we can both move. It's a little bit too slow maybe, and beside that we can also change speed of our moving capabilities like that. Maybe create some obstacles now falling on us, because I think that this will be a game when you have your player here, there will be obstacles coming like this. Imagine this old game called Chicken Invader. I don't know if you've played it, but if not, then you can try it. It's great. Okay, I'm going back to my main scene because I prefer to do it like this. I will create here. I will add a child here. This also will be a character body tree. You can also press this plus here and create a new scene, but it seems more convenient to me to do it in here. I'll rename this one to the obstacle. Obstacle. I will once again add a sprite to it. I'll go into the visual editor. Obstacle is here. And as a sprite, as a placeholder, I will once again use the icon, but maybe to spice things up, let's again go to the transform scale, turn off the component ratio, change only, no, I messed up, revert, change only X, so that this will be like falling blocks, and go to we're looking for modulation, invisibility canvas item. Modulate it to black so that this will be easy scanning this way. What's the word? Distinctive, I think. So that this will be clearly different from the player. Now let's also save this branch as a scene, but not in the player. Let's create a folder called obstacle. Save it in here. Once again, remove obstacle from the main scene. Okay. And now we will spawn obstacles in here like our player, but we don't want obstacles to stay in place. So I double clicked in here. It opened an obstacle tab in here, but it doesn't have a script, so let's also attach a script, obstacle in obstacle, create. But here, unlike in a player script, we don't want to be able to control them, we want them to be like, I don't know, falling, imagine falling down. So let's once again create a variable called speed. Let's give it speed of 200, and once again function physics process, and here we want the obstacles to be falling down. So once again, let's use the move and slide function, but we don't have to, I mean, if you want you can, but I don't have to be checking for the input or other changes to velocity, at least for now. So I can just grab a ready function and one time only set obstacle velocity to the vector 2 down, This is equal to vector 2, 0, 1, if I remember correctly. This one multiplied by speed. And now when I run this scene only, the obstacle should be falling down. Let's check. Okay, as you can see, obstacle is falling down perfectly. There is another problem in here, but okay, delta is never used. Let's add underscore to delta, so that it's not an error. This is a warning. So the warning will not be showing up. As you can see, the warning is not showing up anymore, but the other problem is that the obstacle is getting spawned, but we never remove it. So it will stay and stay and stay, and it will keep wasting our memory, and at one point in time, with enough obstacles spawned, the game will crash, or yeah, it will probably just crash. So we need to detect obstacle leaving the window. Lately I found out that there is a node called screen visible. Wait, let me check the documentation. Visible on screen enabler. Okay, this is something similar, but it doesn't remove. We want to be using not this one, but the visible on screen notifier. This visible on screen notifier got something like screen exited signal built in. So now we can either connect it from this window, which I don't recommend. I recommend doing it from a code. It's much more cleaner, and because signals sometimes weirdly disappear if you move scenes, so I try to only connect them from code. Here we can once again, wait, I put it on top, so let's again put it on top. You can once again create an export variable. Can I put it like this maybe perhaps? No, you can't do it anymore in this version. Was the visible on screen notifier. I will call this variable visibility notifier. This one will be of a type of visible on screen, not enabler, notifier, not enabler. Remember, I mean, if you mess up, you will get an error, and that's it. And we need to assign a node. Okay, we need to press in here, and now we can drag it in here. And while the quick digression, while the signals weirdly disappear, if you connect them from here and there are some kind of problems, then this export variables in here are the sheet. They are node moving in the tree manually proof. So if you move the nodes in the tree here, they will automatically adjust. So I also recommend using this instead of the string paths. And if we now that we've got a reference to our visible on screen notifier to the node, we will connect a signal. Let's do it in here, and this is it's done like our node dot name of the signal. Wait, what? Where is it? Okay, we've had a character to be highlighted. We want the screen exited signal, and now we need a method. We'll create a new method in here. Call this one, or do I even have to? Okay, step by step. Let's first call this one remove, and he will simply use the q3 method. This one removes the object that it was called on from the tree, and we have to, if we want to do this, put this method in here. Why is it crying? Oh, I know. We have to drop a connect in here, and now it's called proper. Now when the maybe to show you, I will do print 0 in here. Now pay attention, or maybe not, wrong button. Pay attention to the console here. When this disappears, the 0 is put on the console. So now if I go back, and I will be very fast, pay attention to the tree on the left. I will go in here, throw on remote, obstacle. We've got an obstacle, and it disappeared because it went off the screen. I wasn't fast enough to show you, but you probably get an idea. And now the question is, can I just call a Q3 in here? Let's check. No, I can't. It returns void. Can I use a lambda function? Okay, I think it's done. Like function brackets semicolon. Okay, let's try. Okay, perfection. It disappeared, but wasn't it too fast? Check. It disappeared when the node disappeared on the screen, but not when the sprite disappeared. So let's try setting this one as a child of a sprite then. But on the other thought, this doesn't change anything because the visible node is simply placed in the middle of this body. So let's go to the visual editor. Okay, you can move it like this with the mouse wheel. And here, let's also turn on the snapping. Use smart snap. Use grid snap. What's the smart snap? I don't know what's the smart snap. And while on our visible screen node, that's okay. Maybe that's the smart snap. Probably yes. Let's expand it so that this will be a size of our sprite. And now, sorry, wrong button. And now, when the entire sprite disappears, it will disappear from the tree. Okay, perfect. If you're curious, you can. I am using F5 to run project, and the F5 runs the main scene that you can set it the settings. If you messed up, you can go to the project settings and something like main. Okay, main scene here in the run, you can change it, or you can simply run a current scene by F6. So this is where the weird things were coming from. And now we want to spawn the obstacles in our main scene, so let's go to the main GT script. Here, the same as we're doing with the player. Let's make an obstacle here. This will be a character body. Let's go to the preloads. Thanks. And here let's create obstacle preload, but this time oh, come on, give me hinting. Obstacle obstacle tscn. Now go back to the main. The only thing we need to change it here is that we want to have multiple obstacles, and we're grabbing instances. So the let's not call it obstacle, let's call it obstacles, and we'll make an array of character body to this. Now we can grab all of this, or maybe let's not grab all of it. Okay, let's not copy anything, it will be faster. We'll make obstacles dot append to our array, and here we'll be doing preloads obstacle dot instance. I will show you what's the problem. Okay, if we make it like this, and even let's take this. Okay, we'll use the replacing tool. Obstacle. Okay, replace. Okay, I'll have to change that one. Okay, obstacle. I don't know why doesn't it hint me. It should be hinting it because I've made a type here. Okay, let's ignore it. And why is it crying? In the fire obstacle. Okay, good now. Also spawn it the 1/4 of the screen and spawn it on the top of the screen. So now we'll have something like this. As you can see, it's very decent. The problem is that if we want to add another one, let's say in here, let's look how it looks like. As we can see, the first one disappeared. Yes, because it's already got the stuff in. That means that we have to create an array of obstacles. And here will be simply appending to our array, and we'll be grabbing the last one, the last previously added to the array. It will be changing in its position, and then adding this one as a child. You can do it as many times as you want, and it's probably better to put all of this spawning in some kind of a function. I don't know yet, so I won't be doing it. And now I can simply append another one and change the position here, and we'll have two obstacles falling down. But the problem now is that there's zero collision between us, player, and the obstacle. There are many ways to handle collisions, or at least a few. Here I will be using collision shapes. As you can see, we've been having this yellow warning sign here saying that this doesn't has a shape. So we'll add a collision shape child, collision shape 2D. We'll go to the editor, press on the collision shape, add a shape. We'll be using a rectangle here, expand it a little bit. The same thing we'll do with the player. We'll add a collision shape once again. We'll make it a rectangle once again. Let's turn on the grid snap increase, but now it still will be doing nothing. Oh no, it's already worked. Okay, so that's surprising, because the way this is controlled is here in the collision tab. We have layer and mask here. Here in the layer you specify on which layers do you count on being. So for example, this layer is on the layer 1. You can also rename it, what I also recommend. And while being on layer, and you can be on multiple layers, you will collide with entities being on specified mask in here. And what's the mask? While the player is on layer 1, then for other bodies, entities or whatever, it counts as being on the mask 1. So now if I turn off the mask 1 here and turn on the mask 2, so player is on the layer 1 and collide with mask 2, and I will go to the obstacle here to the collision once again, and I will set it on layer 2 and collision with with mask 1. It means that the player on the layer 1 here will be colliding with the obstacle on layer 2 here, and here obstacle being on layer 2 will collide with the player on layer 1. Okay, as I will also rename layer 2 to the obstacle. I will be renaming layers, but I will keep the mask names are default. I don't know yet if this is a proper convention, but yeah. Okay, let's check if this works. It should work. Okay, it works perfectly. I hope that you understand how collisions work. The last thing that I will do now, I want to be able to detect collision, but I want to be able to detect collisions on the player side so that I won't be detecting collision from every obstacle but only from the player, so that I can code getting hit or whatever. I will go into the player script. Here you can move and sign function returns the collision detection, or we can check what does it return. It returns boolean if collided. So we can make if body and slide and you're able to detect collision here like this. Okay, so that will be it in this one, and I will continue in the next one.